Hello everyone, David Wilson here for Dr. Stemcells. It's been winter here, so as you can see I have a changed background, a little bit more in keeping with the current conditions. We just had a lot of snow in Ireland and Norway has just had an awful lot of snow. And in today's video I thought maybe I should get back to basics. I received some feedback on my videos that I'm much too in-depth, there are much too many details. We just spend far too much time going into things which I think are interesting. And of course my job is to work as a stem cell doctor. Hence the name of the channel. I give patients treatments with regenerative medical techniques. Stem cells and PRP are the mainstay of treatment within this branch. I want to talk about this. This is my 8-year-old. He came to me one day and said, I have made a poster for your work. And I don't know if you can read it, but I'll read it to you now. He copied over he had first written in pencil and then he drew over in felt tip. So that's why it's a little bit double writing. You can see a shadow behind the letters, but it's all his writing. I haven't written it for him. He just asked me how to spell some words. So here he says, come visit Dr. Stemcells. He can give you PRPs and stem cells. And then there's a big stem cell. Now I had to help him with what a stem cell is, how it looks, and he's drawn it. You can see a syringe there in the middle of the screen. And he says, doesn't hurt. And then underneath he's written, well, you can barely feel it. Now I thought it was very insightful. I must have, some of what I talk about must have broken through, because he clearly knows that there's a little bit of discomfort you can expect with these treatments, even though they're not terribly painful. So in this image, it's an interesting image because here we have a cell in the middle. So let's talk briefly about this cell in the middle. You can see the pink cell, and I helped him draw this. The black bit on the top left of the cell is the nucleus. That's where the DNA is stored in the cell. The green areas around the black are supposed to be endoplasmic reticulum. In my day, we learned about rough and smooth endoplasmic reticulum as though they were two separate things. It turns out now with advanced technologies and microscopes, we know that the endoplasmic reticulum is the same. Smooth and rough are just different processes. One is forming the vesicle and the other isn't. And then, of course, you have the little dots, which are the vesicles inside the cell contents. And, of course, the pink background to it all is the cytoplasm. There is a cell wall there you can't see, and there would be other structures, probably mitochondria, which produce energy. There might even be vesicles inside the cell which are containing instruction, or mRNA or miRNA, microRNA, whatever. There will be different processes ongoing for every different cell type. Now, a cell like this, a stem cell, is a cell which is a progenitor to something else. In other words, it is a father or mother cell to a different lineage or a different cell than itself. So what exactly is a stem cell? A stem cell is a cell which can become something else. In the most basic of terms, the essential stem cells are sperm and egg. Now they contain half of the genome each, 23 chromosomes, and when they meet, they form one whole new organism which will grow into a complete person. Now that's quite impressive when you think about it. One cell starts off in the womb, it implants, and it grows into an entire baby. That means that one cell must have all the instructions capable for all functions of life. Indeed, some functions that the baby itself would not hope to experience during its pregnancy and then afterwards. Things like healing and repair. Really, you would hope a baby does not have to undergo that, neither in the womb nor shortly afterwards. And yet the instruction set is all present. This means that the cells that can divide into different classes. So you have different lineages of stem cells, and these stem cells then perform different functions and become different types of tissue. One way to look at it is you can think almost layer by layer, that we have the outside layer, the ectoderm, we have the middle layer, the mesoderm, and we have the inside layer, the endoderm. Each of these layers then become a different part of the process. They become a different type of cell. So if you think that we have our ectoderm, it's going to become things like skin and hair, follicles, maybe even some of the mucosal membranes or some of the other parts of the body which are exposed to the outside world. The mesoderm, on the other hand, is responsible for most of the organs. It can also be bone, muscle, and many of those internal structures which are not visible to the outside world but are close to the surface will come from the mesoderm. Finally, we have the endoderm, and it's going to be the deepest structures, if you want to think of that in terms of physiologically. We have these most important structures, things like nerves and neurons and the nervous system, the brain. All of this will come from that endoderm. A stem cell then is a cell which is part of this lineage. It can become something new. And when we talk about stem cell treatments, we're actually talking mainly about things like mesenchymal stem cells, which we use from fatty tissue or bone marrow to try and help patients with sports injuries, musculoskeletal problems, and they can become one of four things. They can become fat, muscle, bone, or cartilage. On the other hand, you'll often hear people talk about stem cells like stem cells for their cancer. So people who have leukemia or different types of lymphomas may be getting stem cell transplant from a stranger or from someone they know to try and help improve function. And they'll actually, during that process, take their own immune system cells out. They'll give them poison to destroy them, or they'll treat them radiologically. Usually they're given chemotherapy to destroy the immune system, and that is replaced by this foreign stem cell, which then grows into a fully functioning immune system. The downside with taking someone else's cells for your own use is that your body will try to have this immune fight where your system, whether you've replaced the immune cells or not, will start to fight against itself as it recognizes that some of this tissue is foreign. On the other hand, a regenerative stem cell treatment from your body for your body isn't going to cause you any rejection because those cells are from yourself for yourself. That's called autologous. And an autologous stem cell is one which results in your body having access to resources which were simply in another place. So although it's a transplantation, it's really an auto-transplantation from yourself to yourself. So we simply take some fatty tissue, we centrifuge the cells out of it, and we can inject those into different joints or tissues. This being the case then, an autologous stem cell treatment means that you've taken cells which are unfinished in terms of their maturity. They haven't decided what they're going to be when they grow up, if we're allowed to say it like that. And that means that these cells are then ready to become something new. If you put them into a joint, they're going to coat the joint surface. They're going to result in changes to that joint surface, hopefully improvements. But if you put them somewhere else, like perhaps into a damaged muscle or other tissue, they can also become that cell type within muscle, cartilage, bone, and fat. On the other hand, there's more and more research coming out now that if you put these stem cells into a different area, a different target, they, instead of becoming new tissue like cartilage or muscle, they can actually improve immune response and help guide the immune system to understand what the problem is and hopefully to provide a solution for that problem. For example, by giving intravenous stem cells, we have seen some patients make remarkable improvements, even recovery, from diseases like MS, ALS, Parkinson's, dementia, Alzheimer's. And these diseases affect the brain. So a patient with a brain problem, a cognitive decline or a decrease in neurological function has actually been seen to have stability or improvement in some cases. On the other hand, this is not guaranteed as these studies are small, early safety studies mainly, and in many cases we're looking at small groups of data which show that it's possible to have an effect and it can happen. It's statistically significant, so it's not just random chance, but we don't know how many people in a general population this would affect. So there are still questions that need to be answered. Then the next question is, well, if that's the case, should one take stem cells from yourself or from someone else who donates? And this is where we start to get into more difficulty understanding when a stem cell treatment should be given from yourself for yourself, that is to say autologous, or when you should receive an allogenic donation or purchase from some other person. In cases of cancer or other susceptibility where your body is actually broken down or not functioning, maybe the allogenic, the transplant from someone else, is the only option. However, in cases of your own body having problems which are not directly related to the cells going wrong, so rather injury or trauma or some other kind of breakdown which is really more exogenous outside of yourself, in those cases you might find that an autologous stem cell has a lower risk profile. These are the questions we try to answer on this channel, and we'll be putting this video out. I hope you find something useful in it. If you have questions, please let me know, and I'm trying to make it simple, so if there's things you don't understand, please also let me know so that I know what to try and simplify and go into more detail on. Thank you for your attention. Thank you for coming with me in this journey, and I hope we learn together every day. Have a great day. I'll see you in the next one.